Okay, Euclidean Geometry Part 22 of 25. In this video, we are going to prove the Proportionality Theorem. So, in order to understand how to prove the Proportionality Theorem, I believe you have to know how to choose the height of a triangle whenever calculating the area of a triangle using the following formula. So, how to choose the height of a triangle when calculating the area of a triangle. Okay, so when using the following formula to calculate the area of a triangle, the length of the perpendicular height of a triangle will always be used. Okay, so when using the following formula, area of a triangle is equal to half times base times height. How can you choose the correct height when calculating the area of a triangle using this formula? So, if you have a right triangle, this is obvious. AB is perpendicular to the base BC. So, using this triangle, if you consider BC to be the base, you can see AB is perpendicular to BC. So, AB is going to be the perpendicular height. So, this is going to be the height to use in this formula because AB is perpendicular to BC. So, the height is equal to AB. If you draw a line that coincides with the base and you draw another line parallel to this line passing through this vertex, you can have a line as this one perpendicular to this line. This is also the height that you can use in this formula. Okay, you can have a line as this one between the two parallel lines perpendicular to this line. This can also be considered the height to be used in this formula, or this line perpendicular to this line. This can also be considered the height to be used in this formula. So, in the case of a right triangle, this is obvious. Now, if you have a triangle as this one, the height to use is not KL or KM. You have to use always the perpendicular height. So, you are going to draw a line from this vertex perpendicular to the base. So, this will be the height to be used in this formula. Okay, if you draw a line that coincides with the base and you extend it a bit and you draw another line parallel to this line passing through this vertex K. This line perpendicular to this line can also be considered the perpendicular height to be used in this formula, or this line perpendicular to this line can also be considered the perpendicular height to be used in this formula, or this line perpendicular to this line can also be considered the perpendicular height to be used in this formula. Okay, you can also have a triangle as this one. So, PQ is not the height to be used in this formula, or PR is not the height to be used in this formula. You're always going to use the perpendicular height. So, to get the perpendicular height, if you consider QR as your base, you can extend QR like this. Now you have this line from vertex P perpendicular to this line. Now this is going to be the height, the perpendicular height to be used in this formula. You can see, you can also draw a line that coincides with the base, and you draw another line parallel to this line passing through P. Now this line perpendicular to this line can also be considered the perpendicular height to be used in this formula, or this line perpendicular to this line can also be considered the perpendicular height to be used in this formula, or this line perpendicular to this line can also be considered the perpendicular height to be used in this formula, as long as the line is between the two parallel lines and the line is perpendicular to one of the line. Okay? You can also have a triangle as this one. So xy is not the height, xz is not the height. So if you consider yz to be the base, now to get the perpendicular height, you can extend yz. Now you are going to have this line perpendicular to this line. Now this is going to be the perpendicular height to be used in this formula. Okay, so you can have a line that coincides with the base, and you draw another line parallel to this line passing through x. Any line between these two lines perpendicular to this line or this line can also be considered the perpendicular height to be used in this formula. Okay, you can have this line perpendicular to this line. This line can also be considered the perpendicular height to be used in this formula. Okay, let's move on. Now you know how to get the height of a triangle. So we are going to prove the proportionality theorem. So you are given triangle ABC and the line DE parallel to the line BC. Okay, so you are given the triangle ABC and the line DE parallel to the line BC. Now you are required to prove, okay, RTP, you are required to prove that AD over DB is equal to AE over EC. Okay, solution. The first thing is to start with construction. You are going to start with construction. Okay, join the vertex B to E and the vertex C to D to form the lines BE and CD. Okay, BE and CD, and you're also going to draw the line EM perpendicular to AB and the line DN perpendicular to AC. Okay, EM, this is E, so EM is perpendicular to AB. This is AB. Okay, so you're going to have EM perpendicular to AB and the line DN, okay, DN perpendicular to AC. Okay, DN perpendicular to AC. Okay, so now the proof. Okay, you need AD over DB. Okay, so can you see? You need AD over DB. Okay, so you need this triangle. Okay, the triangle ADE, because you have AD, and you need the triangle BDE because you have DB. So we are going to have the area of this triangle. Okay, area of triangle ADE over the area of the triangle BDE. Okay, so this is equal to the area of this triangle is equal to a half times base. The base is AD times the height EM, now over the area of this triangle, which is a half times the base, which is DB, times the height is EM. Can you see? If you extend DB like this, can you see the red line? If you extend DB like this, now you can see from E to this line you have the perpendicular height. So EM is the height to be used. Remember from the previous slides. Okay, so you can see now this is equal to, you can cancel, okay, this and this. Now you have AD over DB. So we are done on this side. Now on this side we are going to have AE over EC. Let me show you. AE over EC. Okay, so we are going to use the area of this triangle. Okay, the area of the triangle ADE over the area of the triangle CDE. Okay, this triangle. So this is equal to the area of this triangle. This triangle is equal to a half times, now you are going to use AE as the base, times the perpendicular height is going to be DN. Okay, because DN is perpendicular to AE. Okay, so AE is the base and DN is the height. Okay, because DN is perpendicular to AE. Okay, so this is over. Now the area of this triangle is equal to a half times, now the base is AC, times DN. You can see if you extend EC, can you see? If you extend EC, you are going to have DN is the height, because DN is perpendicular to the base AC. Okay, so you have is equal to, you can cancel. Okay, you have AE over EC. Now let me show you. Okay, let me show you. So now you are going to take this triangle and this triangle. The area of this triangle is equal to the area of this triangle. Okay, let me show you why. So the area of this triangle BDE, okay, is equal to the area of the triangle CDE. Okay, why? Can you see? If you choose DE as the base for both triangles and you have the height is also equal, so the area of this triangle is equal to the area of this triangle. Okay, so the reason why the area of this triangle is equal to the area of this triangle, you are going to say common base DE. Okay, DE is a common base for both triangles and you have the same heights between these lines that are parallel to each other. I can show you that. Okay, so for this triangle, the triangle CDE, if you extend the line DE like this, now you can have the height which is perpendicular to this line. Okay, so this is going to be the height for this triangle, the triangle CDE. You have the height between the parallel lines. Okay, you can also get the height for this triangle, the triangle BDE. Okay, if you extend the line DE like this, you can have this line perpendicular to this line. Okay, so this is the height as well. So this height is equal to this height. You understand? The area of this triangle is going to be equal to the area of this triangle because you have the same base and the same height. So this ratio, okay, so this ratio is equal to this ratio. So the reason is common area of triangle ADE in the numerator, and in the denominator you have the area of this triangle is equal to the area of this triangle. This is proven, you can see. So therefore this is equal to this, equal to this, is equal to this. Okay, we have proved. Okay, we have proved. So this is proof number 1 of 3. Okay, some additional information. Triangles with different bases but equal heights are not equal in area. However, the ratio of their areas is equal to the ratio of the lengths of their bases. Okay, so you have triangle ABC and triangle ACD, ABC, and triangle ACD. You can see the height AE for triangle ABC. The height is AE. AE is perpendicular to the base BC. And for triangle ACD, the height is AE as well. You can see AE is perpendicular to the base CD, but you have the bases are different. Okay, BC is not equal to CD. Now the ratio of their areas, okay, area of triangle ABC over the area of triangle ACD. Okay, so this is a ratio. So this is equal to a half times the base for this triangle is BC. Okay, BC. This is the base for this triangle, and times the height, which is AE. Okay, for the triangle ABC, the height is AE. If you extend the line BC, you are going to have AE perpendicular to BC. So this is the height for this triangle. Okay, over now the area of this triangle, you have a half times the base, which is CD, times the height, which is AE. Okay, now you can cancel a half and a half, AE and AE. Now this ratio is equal to, you have BC over CD. Now you can see the ratio of their areas. Okay, this is the ratio of their areas. Okay, the area of triangle ABC over the area of triangle ACD is equal to the ratio of the lengths of their bases. Okay, BC over CD. Okay, you can see. So please check lesson 23 of 25. We are going to learn about the ratio of areas of triangles. Okay.